Hey everyone! Welcome back to our channel. Today, we're diving into SpaceX's Starship and the challenges it's been facing with its heat shield tiles. If you enjoy our content, don't forget to subscribe and hit the like button for more space news and updates. When we hear about SpaceX's launches and all the tests they conduct on the Starship, it might sound like a walk in the park. However, we need to remember that the Starship is the world's largest and most powerful rocket ever developed. Not even legends like the Saturn V are as large and complex as the Starship. Despite its enormous size, Starship aims for full reusability, making it even more complex. This means that every component of the rocket is crucial, and if one part fails, it can ruin the entire mission. One part that SpaceX has been having problems with for a long time is the heat shield tiles. These tiles have faced issues on all 4 launches of the Starship. SpaceX has now realized the seriousness of the problem and is taking some brilliant steps to resolve it. In this video, we'll talk about these developments. The most difficult and intensive part of a rocket launch is the re-entry phase. This is because the spacecraft must withstand extreme temperatures and forces as it travels back through Earth's atmosphere. The heat shield tiles are crucial for dealing with this challenging part of the launch. In engineering, a heat shield is designed to protect an object from burning or overheating by absorbing heat. No spacecraft can re-enter Earth's atmosphere without a heat shield, and it is a critical element of SpaceX's ambition for fully reusable rockets. Despite the impressive performance in the 4th launch, there was instability with the heat shields, specifically a weak point between the flap and the main body of the Starship. This vulnerability nearly compromised the spacecraft as the intense heat during re-entry caused considerable damage to the flap. Remarkably, Starship managed to complete its landing with the flap still functioning, demonstrating the spacecraft's robust design and resilience. In rocket engineering, a heat shield is designed to protect an object from burning or overheating by reflecting or absorbing heat. Without a heat shield, a rocket cannot last for even a second during re-entry. The material Starship is built from, primarily stainless steel, can withstand temperatures up to around 1,500 degrees Fahrenheit. However, the heat shield tiles on Starship need to endure much higher temperatures. In the 4th flight, the heat shield could withstand external temperatures of up to 2,600 degrees Fahrenheit, which is hot enough to melt aluminum. Musk plans to improve the heat shield and landing capabilities of their reusable Starship. The first solution proposed is to replace the entire heat shield with new tiles that are twice as durable as the previous ones. The new tiles are about twice as strong and hopefully half as likely to crack or come off. The new heat shield will withstand temperatures up to 5,200 degrees Fahrenheit, a massive improvement. To put this into perspective, the Space Shuttle heat shield tiles, which were made of a reinforced carbon-carbon material, could withstand temperatures up to 3,000 degrees Fahrenheit. While this was sufficient for the shuttle's re-entry, Starship's new tiles are designed to endure much more extreme conditions. The hexagonal shape of the new tiles is a significant design choice. Unlike traditional tiles with straight edges, which can create pathways for hot gases to seep through, hexagonal tiles interlock in a way that minimizes these gaps. The Apollo command module, which used an ablative heat shield, was capable of withstanding re-entry temperatures up to 5,000 degrees Fahrenheit when returning from the Moon. While this was a significant achievement for its time, the reusable nature of Starship's heat shield adds another layer of complexity and innovation. The Apollo heat shield was a one-time use component, burning away during re-entry to protect the spacecraft. In contrast, Starship's heat shield needs to be robust enough to survive multiple re-entries with minimal maintenance. Although Musk plans to double the durability of the heat shield tiles, this is no small feat. The engineering challenges involved in such an improvement are significant and complex. The heat shield tiles are made from specialized materials designed to endure the extreme conditions of re-entry. Enhancing their durability requires innovative approaches and advanced material science. The primary material used in Starship's heat shield tiles is a type of ceramic composite known as silicon carbide. Silicon carbide is renowned for its excellent thermal conductivity and low thermal expansion, making it ideal for high-temperature applications. This material can withstand temperatures up to 2,600 degrees Fahrenheit in its current form. However, to achieve the goal of withstanding temperatures up to 5,200 degrees Fahrenheit, SpaceX is developing new formulations and manufacturing techniques. This strength is not just about withstanding higher temperatures but also about resisting the mechanical stresses that occur during launch, flight, and re-entry. The tiles need to remain securely attached to the spacecraft, which requires robust adhesives and mechanical fasteners that can endure significant thermal expansion and contraction without failing. In addition to the primary heat shield tiles, SpaceX is adding an extra protective layer underneath called an ablative layer. Think of this as a backup plan. If the main tiles get damaged or fall off, this secondary layer will take over to keep the spacecraft safe. The ablative layer works like a candle burning down. It's made from special materials like phenolic resins and carbon composites that slowly burn away when they get really hot. As they burn, they absorb a lot of heat, preventing it from reaching the spacecraft's main structure. This way, even if the main tiles fail, the ablative layer will protect the spacecraft from extreme heat. This dual-layer approach is like having a fireproof jacket over a heat-resistant suit. The outer jacket takes most of the heat and burns away while the suit underneath stays intact, providing an extra layer of protection. This makes the heat shield more reliable and ensures the spacecraft can survive unexpected problems during re-entry. SpaceX plans to implement these new heat shield methods on the next Starship prototypes, so we can expect better performance on the fifth flight. The fifth flight test of SpaceX's Starship is expected to take place no earlier than late July 2024. This test will feature Ship 30 as the upper stage and Booster 12 as the first stage. Significant upgrades have been made to enhance the heat shield's durability, including the new tiles that are twice as strong and the addition of an ablative layer beneath them. This upcoming flight aims to demonstrate not only the improved heat shield but also other critical systems. SpaceX has conducted extensive testing, including static fires, to ensure all components are ready for the flight. The FAA has confirmed that no mishap investigation is required prior to this launch, which clears a significant hurdle for SpaceX. That's all for today's update. If you enjoyed watching and found it useful, please make sure to subscribe to our channel and hit the like button. Thanks for watching, and I'll see you in the next one.